I'm the host, huh?
Yes, ma'am. I will just start.
Saloni, please start.
Yes, ma'am. A very good evening to all. On behalf of TLC Ramanujan College and Indian Accounting Association, I welcome you to today's session of the FDP on Advanced Research Methodology and Multivariate Data Analysis. Today, we have our resource person, Professor Madan Lal Sir. Professor Madan Lal Sir is a professor in the Department of Commerce, Delhi School of Economics, University of Delhi. His educational background includes BA, MBA IB, MA Economics, PhD, and DLit. Sir has more than 16 years of teaching experience at Faculty of Management Studies, Banaras Hindu University, Varanasi, and Department of Commerce, DU, at postgraduate level, teaching MBA, MPhil, and PhD students. His areas of interest include international trade and marketing, managerial and international economics. He's also a supervisor for PhD and MPhil research scholars. Sir has worked on a number of research projects, including projects sponsored by ICSSR on the title and analysis of trade, economic growth, and poverty in India. Sir has a number of books and research papers to his credit. He's also presented various papers in international and national conferences. Sir has held key positions like member governing body Hansraj College, University of Delhi, convener examination, Department of Commerce, DSC, University of Delhi, and a lot more. Lastly, he's also a reviewer of International Journal of Intercultural Information Management, published by InterScience Publishers Limited. Sir, I don't think I've done justice to your introduction, yet we're absolutely honored to have you with us in this learning journey. Without much delay, over to you, sir.
Thank you, Slody. You have given a long detail of biodata. Thank you for your kind words. And I'm thankful to the organizers, Dr. Anjali Gupta also, and the Ramanujan College, and the, the organizer who have organized this refresher course. So today's topic is exploratory factor analysis or factor analysis. I'll first discuss with the PPT certain things which are conceptual in nature, and then we will have some practical session on factor analysis. So let me share my screen. Can I share my screen now?
Yes, absolutely.
Okay, it is there, right.
Yes.
So if it is
It's
legible
visible,
to you,
sir.
okay, visible, right, good. So small note that this factor analysis which I am going to discuss, I assume that the participants they are having some elementary knowledge of factor analysis. Taking into consideration that thing, I am going to discuss this. So I would like to discuss each and every aspect of this factor analysis, uh, especially the exploratory factor analysis. So when we talk about the factor analysis, it comes under the multivariate techniques of data analysis. We have dependence techniques and interdependence techniques. May I know who are the participants and from where they are? A brief detail of the participant.
So we have research scholars, we have doctors, we have a mixed pool of researchers amongst us
Okay, and
from all fields, finance, OB, HR, from all fields.
okay, right. So, when we talk about dependence techniques, we discuss these techniques based on whether there is one dependent variable or more than one dependent variable. If we have one dependent variable, then analysis of variance, covariance, multiple regression, and conjoint analysis we do. And if more than one dependent variable are there, then multiple analysis of variance, covariance, canonical correlation, and multiple discriminant analysis we do. There are other techniques in multivariate technique analysis, that is interdependence techniques, where we have variable interdependence and object interdependence. When we have variable interdependence, we use factor analysis, and when we are having object or inter-object similarity, then we are using cluster analysis and multidimensional scaling. So here we are going to discuss factor analysis. So we will see that there are 7 stages normally for analyzing doing this factor analysis. We'll see that how exploratory factor analysis is different from a confirmatory factor analysis, and what are the differences between these two, and how do we extract factors, and how we name these factors. So starting with the exploratory factor analysis. Uh, this exploratory factor analysis, as we have seen that it is an interdependence techniques where we try to see the structure of variables, and we try to analyze these variables. So basically, the purpose of this exploratory factor analysis is to summarize the things, or to uh, reduce the data, or they called as data reduction. So this is how actually we take this correlation matrix, and uh, then we will have first this correlation analysis. On the basis of that, we will see that which are the variables which are correlated to each other, and normally this type of structure we can make where a model graphical model appears, and which talks about how these factors are related to each other, how much they have relation with the other variable called as loadings, and then how this the latent variable which is there is having the variance which is explained by these uh, items. So these are the different stages of factor analysis, and this is the first is objective of factor analysis, designing a factor analysis, assumptions of factor analysis, deriving factor analysis factors and assessing overall fit, interpreting the factors, validating the factors, and additional uses of factor. I would like to tell you that my this presentation is basically based on the multivariate data analysis by here, and others authors are there. So this most of the examples which are taken that are taken from this source. So objective of the factor analysis is whether it is exploratory or confirmatory, what is the specific unit of analysis, and whether the purpose is to reduce the variables or summarize it, and what are the other uses after you use the factor analysis, then how do we use it further. So when we talk about data summarization, then we this when the variables are large number of variables are there, and the summary of the variable is provided, called as summarization of data. When we talk about a reduction of data, in that case the factors which are there, we can take factor score from these factors, and suppose there are 50 variables and we have only 5 factors, so that means there are 5 reduced factors which represent the whole 50 variables. Then we can actually take these 5 factor and go ahead with the analysis. So when we talk about these two types of factor analysis, one is called as exploratory and another is called as confirmatory. Exploratory as itself, the literal meaning is the exploration. That means when we don't have any idea about the concept, then we want to explore it. So once we want to explore it, then this exploratory factor analysis is used. That means we don't have many prior information about the uh, the factor structure. Just a minute. One second. Sorry for interruption. There is actually exigency. I wanted to go somewhere for exigency, but I thought that I have given time, so I'll make use of that. So if I go early, please excuse me. I am fast, little faster, right? Uh, so uh, we were talking about exploratory factor analysis. We don't have any idea of which factor is going to have what relationship with other than exploratory factor analysis. When we have some theoretical background that there is certain structure appearing in the variables, then we use this confirmatory factor analysis to confirm that these are the variables which are put in one particular say structure or one particular factor, and then they are tested to see whether they make some meaningful structure. Actually, the already structure exists, but we are testing it to know whether they actually statistically also fit for this factor or not. Uh, For designing a factor analysis, we have two types of analysis. One is called as R analysis, and then one is called as Q analysis. When we talk about R analysis, that implies that we want to have analyzed the characteristics of variables, and when we talk about Q analysis, then we want to have characteristics analyzed of the respondents. And then we also see that how many numbers of variables are there to measure, and then what types of variables are there, and what sample size is necessary for factor analysis. This is just one example of Q factor analysis and cluster analysis. That in the case of Q factor analysis also, we are going to have analysis of the respondent, and in the cluster analysis also we see that how one respondent is having distance from the other respondent. So if we see this table and diagram, there are four respondents A, B, C and D.
Excuse me, sir.
Yeah,
Your screen is just showing factor analysis and no slides are moving.
okay. Now it is moving or not?
No, not yet.
No, sir. No, sir.
Sir, no, sir.
Okay. Let me
Not
see.
at all, sir.
Okay. Let me again go to it and then see whether it works or not.
Now it's fine.
No.
Yes, sir, now it's fine.
Yes, sir.
Okay. So I was discussing about this one. Yes, Q analysis and cluster analysis. Both are similar, but in the case of cluster analysis, we see the distance between one variable and the other variable. If you see A and B, A and B variable in are in the one cluster, and
No,
C,
sir, only objective of factor analysis slide is there. Not able.
now it is not moving.
No.
Okay.
Sir.
So we are seeing the slide which shows
Sir, you will have to
stages
share your
stage
full
1.
screen.
Slideshow from the
Okay.
beginning. You can take.
Okay. Let me uh, again share it.
Yes, sir.
if I share the desktop, I think then I'll be able to share everything. What you are able to see now?
Objectives of
Objective
factor
of factor
analysis.
analysis.
Okay, now.
Objective of factor analysis. Now factor analysis outcomes.
Okay. That means now I have shared the screen, full screen, so it will be working. So I was on. Right. I was on this slide where we were talking about that there are two types of analysis: R analysis and Q analysis. R analysis is about analysis of variables, but Q analysis talks about analysis of the characteristics of the respondents, and this is similar to the cluster analysis. But the difference between Q analysis and cluster analysis is that suppose there are four respondents A, B, C, and D, and they have this responses of A and B are given. A, B, C, D are given for three variables: B1, B2, and B3. Now, if you can see that how these respondents are moving, we can see that A and B respondents are making one cluster and C and D are making another cluster. But if you see that respondent A and respondent C, they are having similar responses, and B and D are having similar responses. So in this case, for A and C, we have Q factor analysis, uh, and cluster analysis. When we talk about cluster analysis, then A and B are making the cluster. Otherwise, if a Q factor analysis is there, then A and C are making the Q factor analysis, which is similar, and C and B and D are there. So this was the small difference between Q factor analysis and the cluster analysis. Now coming to the factor analysis, where we have certain rule of thumb that these must be adhered to when we are using factor analysis. So normally it is said that at least for one factor there should be at least five variables available, and when we talk about the sample size, then also we say that for one variable at least there should be five respondents available. However, if there are 10 respondents, then they are considered to be better. And in any case, whenever we are analyzing factor analysis, at least 50 observations should be there. So that is the rule of thumb which is given by these authors here and others, and also other authors who have used this factor analysis. Okay, can you mute someone? Yeah. Yeah, you can I think mute someone.
തിരിഞ്ഞിരിക്കട്ടെ.
Host, can you please mute? This is Maya. Who is this Maya?
Yeah, you can mute all participants except me, and then whenever required you can actually do that.
Yes.
So after this one set of rule of thumb, we have more rule of thumbs. Whenever they are required, they will be discussed. Then next stage comes that what should be the assumptions of factor analysis. We normally say that whenever we are using this exploratory factor analysis, then we say that there is no underlying structures in the data. That means data does not show any relationship between each other. And the second, if we talk about concept, that means we do not know whether data is having a relationship with each other or not. And statistically, when we can actually use factor analysis, if the factors are intercorrelated, they should have a good correlation. We say that significant correlation should be there as far as statistics is concerned. So now we'll see that how it can happen. When we talk about multicollinearity, this talks about intercorrelationship between the variables. If it is high, then it is called as multicollinearity, and that multicollinearity, and that is the requirement of factor analysis. If there is no multicollinearity, then factor analysis cannot be conducted. And we have uh, uh, these methods which we call it as KMO and called as measure of sample adequacy, MSA, and Kaiser's measure Alkin statistics is there, which gives us statistics that it should not be less than 0.5. If MSA is less than 0.5, that means we cannot conduct factor analysis. And homogeneity of sample factor solutions should be there, that whatever sample we have taken, they should show homogeneity in themselves. So what we do is, whenever we are conducting factor analysis, we see first of all the correlation of all the factors, and the test is called as Bartlett's test of sparsity, which sees that whether the correlation matrix, the full correlation matrix is significant or not. If it is significant, we move ahead and go ahead with this measure of sample adequacy, which is calculated through anti-image correlations, and that also we'll see once we do it. And this should not be less than 0.5. If it is less than 0.5, then also we cannot conduct this factor analysis. When we talk about this factor analysis, we especially the exploratory factor analysis, we have two types of factor analysis. One is called as common factor analysis, another is called as component factor analysis. These two factor analysis are actually differentiated on the basis of the variance they are actually explaining. When we talk about common factor analysis, then it actually is based on the shared variance, both the common plus the specific or unique variance is there. When we talk about component factor analysis, it uses only common factor analysis, so common variance, and it is actually considering the total variance is considered to be the common or shared variance. That we'll see how it happens, and then we'll see that how we determine the factor of this number of factors. We can use principal component analysis and common factor analysis, as we have seen earlier, whether you are using common factor analysis or component factor analysis. That will depend upon what is your objective, whether data reduction or it is data summarization. Then rotation is taken done for these factors, that how to rotate the factors, whether to rotate it orthogonally or oblique rotations are there. So this is the difference between the common variance and unique variance. So when we are using this common variance, then the whole variance is called as h square, and if you want to differentiate it from the unique variance, then 1 minus h square is the variance which is excluded, which is not explained under this method. So whenever we are using this common variance method, we are taking actually these only the shared variance or the common variance. Here you can see that when we are using this common variance on this post sale customer service, this is called as latent variable, and then when we are taking this factor, explains the common variance. All variance is shared by this factor, and it is not able to explain how much is the specific variance or how much is the error variance. That simply implies, if you talk about this factor, for example, I'll give you a small example, like complaint resolution is the variable, and we say that this complaint resolution is explaining certain level of post sale customer service. However, this complaint resolution is also having some variance which is not explained, like specific variance specific to complaint, who has done the complaint, and then what was the reason for complaint, and there can be some error, some specific error, and some random error. So this error is not segregated when we are talking about post sale customer service. This is briefly about this. So when we talk about this factor analysis, we do this with the help of this reflective model and formative model. Briefly, I'll explain, because otherwise time will not permit me to explain it in detail. However, when we are talking about the random or the this error, this you can see that if you see xi is having the arrow towards x1, and then there is delta having arrow towards x1. So xi is the factor, and lambda is factor loading, and x1 means how much x1 loads on xi. However, it is a reflective measure, so the arrow goes from xi to x1, and the delta 1 is explaining that how much error this variable is having. And in this case, you can see that error in x1 is there, and that is why we can see that this is a reflective model. And if you see in the top equation, xi is the function of lambda, this xi plus random error. And when we talk about the same thing with the help of formative model, then in this case you can see that x1, x2, x3, they are not having this random term delta 1. However, they are having covariance with each other. They are having this the arrows, they show it, and then arrow of x1 goes from x1 to the eta, and then you have common error which is reflected by this zeta on the extreme right. And in this case, this is called as formative model, and reflective and formative is small explanation I'll give that. In the case of reflective model, when we are having this reflective model, if we are removing this x1, then the nature of this xi will not change. That means the this factor xi will not change, because this is constituted, or this is accommodated by this xi x1. So x1, if you are removing x1, the nature of the characteristics of xi will not change. However, if you, in the case of formative model, if you change x1 as a variable, then you cannot have this eta named as eta. So that is called as formative model. That means even if you are removing x1, your factor name will change here, factor will change. Especially the example is given of socio-economic status, where we have this okay, there is a question coming in. You are talking about this delta error. We talked about the error which is unique to the variable. So when this x1 is having unique error, and we said that unique error is classified into the specific error and the random error. So this is what is represented by delta. And in the case of formative model, we have this common error, which is here you can see called as uh, this zeta, this common error. So whenever we are having formative model, we have common error here, and x1, x2 and x3, they are related to each other. For example, when we talk about socio-economic status, suppose eta is your socio-economic status, and you have x1, x2, x3 as income and your age and occupation. So if you remove x1 as income, then you cannot name this eta as socio-economic status. Then you have to change it to because age and occupation are there, so you can have this variable, maybe that demographic variable. So this is how formative and reflective model can briefly be explained. Uh, In the case of principal component analysis and common factor analysis, we have two criteria. We see that what are the objectives of, based on that objective, we use principal component analysis, and then on the basis of what knowledge about these variables and their structure is there with us, on the basis of that we use it. So in the case of principal component analysis, as we have seen that whatever variance is there, common variance, that is considered to be a total variance, and it is called as h square in this case, and h square is equal to 1. That means common variance will reflect the whole commonality between the among the variables. There is another way of looking at it is eigenvalues. These eigenvalues are actually able to explain that how much variance these factors are having, which can be explained, that how much variance these individual factors are explaining, and we can identify this with the help of the eigenvalues. And if eigenvalues are close to 0, that means there is multicollinearity is there, and then we'll see with the help of whatever we will be doing this analysis, then we'll see that how this multicollinearity is there, or eigenvalues are calculated also. So how many factors should be there? We have these four criteria. One is a priori criterion, that whatever other methods are using, whatever other say researchers are using, on the basis of that. The second is latent root criterion, third is percentage of variance, and fourth is Cree plot. So you can actually decide that which method you need to use for extracting the factors. So a priori method that you already know from the research or the prior readings, that these many factors are sufficient for such type of studies. You can decide that these many factors will be used. Second is latent root criterion, which is called as eigenvalue criterion, and normally it is the authors say that if eigenvalue is 1 or more than 1, these many factors you can actually take, and these factors the normal length of factors should be between 20 to 50. And if we talk about how much variance these factors are explaining, so it depends upon different areas of study. In the case of social sciences, we normally accept that if 60% of the variance is explained by these factors, these many factors we can take. However, in the case of sciences, natural sciences, 95% explanation is expected from the variable which you are extracting. So that you can also decide that if these variables are explaining 80%. So if factors they explain 80% of the variance, these many factors we will be taking. So this again depends upon the author or the researcher. Then we have scree plot criterion, where scree plot is there. On the basis of that, you can decide that how many variables you can keep. For example, this is a scree plot, and you can see that wherever there is a elbow of this scree plot, up to that many variables actually normally are taken if you are going by the method of scree plot. So in this case, if you see in this slide, if we go excuse me, if we go by the scree test, then 10 factors are taken in this case. However, if you go by the eigenvalue criterion or latent root criterion, then it is about 8 factors, because one and more than one eigenvalue is having 8 factors, and if you go by the scree test, then there are 10 factors. So it depends upon the researchers how many factors they want to extract. It is expected that the respondent should be heterogeneous, so that it will be you will be able to have combine these responses and have a good model. Then there is another rule of thumb which talks about if your objective is to reduce the data, then you have to see that whether theoretically how these variables are supported, and then you will decide that how much communality you can have. So normally it is said that 60.6% is better, or 0.5 above more than 0.5. If it is near to 0.5 to 9, it is considered to be a better one. And then you can interpret the this process of factor analysis by estimating first the factor matrix, then rotation of the factors, then interpretation of these factors, and if suppose there is cross loadings of factors, then you can delete the variables depending upon the method which talks about that whether you need to delete it or you need to check. Actually you have to check and again see 2-3 things whether to delete the variable or not, and that can be checked with the help of how much loading these factors are having on 1 and 2 variables, or what is the initial correlation among these variables, and accordingly hit and trial you can first remove one variable and then see how much explanation is there, and you can remove include that variable and remove other variable, then see that how much explanation is there, and accordingly you can remove if required. Then there is a factor rotation. Normally this factor rotation is done when we actually in the initial stage of without factor rotation we may not be able to have correlation, good correlation among the variables. So in order to have variables independently correlated, we can have rotation method. So there are two types of rotation method. One is called as orthogonal. There are others also, but we use normally orthogonal and oblique. In the case of orthogonal, we actually see that the factors they move independently and the axes are maintained at 90 degree. In the case of oblique, they are allowed to have mixing of these variables. For example, this is orthogonal one where the 90 degree of factor 2 and factor 1, which when they are rotated it is maintained, and however if it is oblique one, then this independent structure is there. So that factors can actually rotate the way they want, they are allowed to rotate. For example, if it is a quadrimax rotation, then when it is a matrix, then we simply rotate the rows. Excuse me. If it is varimax, then we rotate the columns, and if it is equimax, then combination of rotation of columns and the rows is done, but most of the time we are using this Varimax rotation, that means the rotation of the columns, to see that whether any factor, when after rotation, whether they change their position from one factor to another factor, any variable which is changing position from one factor to another factor or not. And normally orthogonal notation is used when we objective is data reduction, and oblique is used when actually you want to derive these factors which are very much consistent with the conceptual explanation of the factors. Uh, Factor loading and their significance, that we will see that uh, as I said, it is 0.5 or above, that will be considered better. But there are authors who say that it will depend upon sample size. If your sample size is larger, then smaller loadings can be allowed. But if your sample size is low, then you should have more factor loading. For example, in this case, when we talk about 0.5, then about 120 sample size should be there, and if it is 0.75, then if 50, we say that at least 50 observations should be there to have a factor analysis. So in that case, your factor loading should be not less than 0.75. So these things are to be kept into mind. It's not that only we say that 50 observations are there and then if factor loading is 0.5 we consider it. That will not give you the good idea of it. And if your sample size is larger, then you can consider actually lesser loading also. This is what actually whatever I have explained earlier, this is the explanation of this, that if it is 0.3 to 0.4, then it is minimally acceptable, and if it is 0.5 and more, then it is practically accepted with all across all the studies. So factor extraction, as we said, that when you are using component analysis, orthogonal is preferred, and it is common, then oblique is preferred. Each loadings of the factors are actually examined, and then wherever, suppose if there is highest loading, that is taken for a particular factor. Then commonalities are also seen. Commonality is nothing but the commonness of factors and the other variables, and then accordingly we label the variable. What will be the naming of the variable is done. If there is one factor which is having high loading of the variable, it is called as optimal structure. If there is a cross loading of variable in the most, then in that case it becomes difficult if there are more than two cross loadings are there. And as far as commonalities are concerned, if there are more than 0.5, the variables are retained in the factor. Validation is done, whether you have a confirmatory perspective of the study, or you want to have factor structure stability, or you want to see the influential observation, which are the influential observation, that can be seen also. Another is there, that if you want to see that what can be the say further use of factor analysis. So that can be once you have identified the factors, and then you can use any other method which is commonly used for any other purpose. For example, whether you want to use it analysis of variance or regression analysis or any other analysis if you want, you can use it. Normally, what happens is there are these three ways of using this variable which are extracted by the factor analysis. One is selecting surrogate variable. So surrogate variable is one where among all the variables in a factor, a variable which is having highest loading is taken as the representative of the factor, so called as surrogate variable. Second is creating summated scale. So in this case, all the variables, the sum is taken of all the variables, and then average is taken, and that average is used as the representation of the factor. Third case may be that computing factor score. So factor scores are computed based on the weightage of the variables, and then this factor score is used for further analysis. And okay, this maximum I have explained, but here convergent validity, discriminant validity, and nomological validity is also on this. From this factor analysis we can have these convergent, discriminant, and nomological validity explained also. That once we do uh, the hands-on experience, then I'll show that how it is done. Representing factor analysis in other analysis, as I have said you, that whether it is a surrogate variable or it is a summated scale or it is the factor score, they have their own advantages and disadvantages. However, depending upon normally the factor score is taken to be a good representative of the factor, because each and every variable is having contribution in that. So these are advantages and disadvantages. I'll take one example which is based on this example, this analysis, which talks about the perception of the consumers regarding the product. And these are the different metric and non-metric variables which are actually used to analyze this. For this purpose, showing you the factor analysis, I'll be using these performance perception variables from x6 to x18, and then actually this was whatever factors are extracted from x6 to x18, these can be used to as independent variable for knowing about the satisfaction of the customer, which is there in the variable 19. Also the first 5 variables, which are called as categorical variable, here we can also use if we are using it as a dependent variable or independent variable, accordingly we can use the statistics for that. For we can use analysis of variance or logistic regression, because these are categorical variables, so the logistic regression can also be used depending upon what you want to have analysis of. So okay, this is actually the analysis which I have done. So I'll show you now the how factor analysis is conducted. I'll take some time to say show you this analysis. Can I have this about 5 minutes, 5-6 minutes to convert to my this practical showing practical?
Yes, sir, please.
Okay, okay. So Are you able to see my screen?
Yes, sir.
Okay, so all operations which I am doing, you are showing.
Yes.
Okay, okay. Actually, I am trying to uh, analyze. What I will do is analyze it uh, because my cutting and pasting is not actually working well. So I'll show how it is analyzed and also show with the help of uh, the analysis which I have done prior to this, how the things happen actually. So if you see this data, I don't know why this problem is there. Uh, that yes, now one has to delete each and every as of these. It will take some time. Uh, Almost all are. I don't know what is the reason. Some problem has happened. But uh, if I go ahead with these cases, then this okay. Let me try that. If missing cases are there, then they will not be considered. But I have to change these variables from string to uh, the numeric, and then all these variables are to be named because all are uh, numeric. So I'll convert these to numeric, right? And also when I have changed it to numeric, it has changed to scale other variable. Though variable number 1, let me check. Uh, yes, uh, in this case variable 1 is nominal, 2 is also nominal, or nominal, as I have shown you the questionnaire. I'll show again. Up to 5 variables you have nominal variables. I don't know whether you have seen it or not. Questionnaire. Okay, I'll go to this questionnaire, and if you see the variables, and this is the questionnaire where you can have this 5 first variables named as this, and then from 6 to 18 variable about the perception, uh, then 19 satisfaction and all. So this is the questionnaire which is uh, surveyed from the people uh, of that particular product. And now you can see these are the variable. If I go to analyze and then dimension reduction uh, for factor analysis. So as I said, from 6 to 18, these are the variable where we are trying to see the perception of the consumers, and these are taken for analysis purpose. And if we see descriptives, then we put this in a initial solution. Coefficient you can have significance level, KMO, which which we talked about, KMO and Bartlett test of specificity, and anti-image. Uh, Continue. Extraction method is in principal. There are another methods are there, but we talked about principal component, and then eigenvalue. Uh, if it is 1 and more than 1, so you decide here itself whether it is 1 or more than 1, or if you want to have scree plot also, you can take here and then see that in both the base whether it is eigenvalue or scree plot, how many factors they actually give. Then rotation was Varimax normally is considered that column, not Querymax. You can go by Querymax also, you can go by Equimax also, you can go by Promax also, and direct oblivion also, but mostly the Varimax rotation of column is used. Then as I said that after factor analysis is done, what do you want to actually use this factor analysis, whatever the variable, how do you want to use it? So if you want to save it, whether you want to use for regression or other Bartlett or Anderson-Rubin test. So if you simply take it as these variable can be uh, saved in the data set as regression variable, so it will uh, give you the these will be added in after variable 23. These whatever factors numbers are there, they will be added in this data sheet. As far as exclude cases list wise, that will do it, and then do the analysis. So this is the correlation matrix. Let me expand it. Yes. So this is the correlation matrix. If you can see, what we wanted to see whether correlation matrix is significant or not, and that is this Bartlett's test of sparsity. If you see this Bartlett's test of sparsity, it is showing point significance level is 0.000. That means this correlation matrix is significant, and we can go ahead. And if you see this KMO, which we talked about, measure of sample adequacy, this is also more than 0.5, it is 0.609. Now overall we can go ahead with conducting the factor analysis, and if you want to check it individually, what you can do is, in the case of anti-image correlation, you can check the diagonal values, like A is written, A is here measure of sample adequacy for each and every variable. So wherever it is less than 5, like for example in this case A variable 11, 0.448, and then you have this variable 15, it is 0.314, and then you have a variable 17 which is 0.442. So you can see these three variables are there which are having less than 0.5 loading, and the loading is lesser with variable this yes 15, 0.314. That means that we need to remove this variable 15, so that the other variable will be able to have more contribution. And also when we are suppose when we remove this variable 15, then you will see that these MSA, measure of sample adequacy, may also change 0.873, or this any of these variable to which this 15 number variable is correlated will change. Now let me show with this limited time. I have already actually calculated this, and I will show you what happens in the first case when you are having this measure of sample adequacy. This is the first correlation matrix of this particular data set, where you can see that I'll briefly explain it. The variable x6 is having this relationship which is significant with three variables. Similarly, are you able to see the screen and able to understand?
Yes, sir.
Okay, so variable 7, this is having significant correlation with three variables. Similarly for other variables also, and if you see this variable 15 is having no variable correlation which is significant, that is why it is 0 number of variables, and that is also reflected in the anti-image correlation. And then variables 17 which is having highest number of correlation. Though these variables seem to be little say need to be taken care of, because one is maximum, one is minimum. So from there itself, from the fact this correlation matrix itself, we can see that how the variables are moving. Similarly, this is KMO statistics, which we have seen in the first case, factor analysis. And now if you go to the factor analysis and uh, remove variable 15 and then see what happens. You go to the variable 15, remove it, and then, because we have set all the things, so we'll see only the result. Now you can see this anti-image correlation is the better way of, or first you check with KMO and Bartlett test. So Bartlett test is significant at 0.000 and 0.612. This KMO has increased from 609 to 612. So that means it has improved. But we can see that individually how many variables are there which are actually now you can see 17 number variable 0.444 and then variable 11 which is 0.449. So this means that 0.444 variable number 17 needs also to be removed from the analysis, because it is having low loading. So okay, so in the case of second, when we have done removed 15 variable, then we have seen that this is 0.612 is measure of sample adequacy. And now if we because from until and unless this is clear, we cannot move ahead, we should not go ahead with the analysis, because individual variable they are causing the problem. So you go with again analyzing the structure and removing variable 17. So remove the variable 17 and then see the analysis. Yes, yes, someone is okay. No sound. I'm not audible.
Miss Anjali?
Hello.
Yes, sir.
I'm audible or not? Hello.
Sir, you're audible.
Yeah, some of the people are saying that not audible. Yes, Anjali.
So that was, you're audible now.
Okay, okay. So what I was saying was that when we have removed variable this 17, then we'll see that what happens to this KMO. KMO is 0.653, it has improved, and your correlation matrix is also significant, and then you can check anti-image correlations now. Now anti-image correlation, you can see that this sixth has reduced now to 0.5. Earlier it was 9, and then you can see, yes, now all the variables they are having a measure of sample adequacy full, more than 0.5. Now we can go ahead with the other analysis like this communalities. I'll show that how these communalities are extracted. Now if we see the first analysis and total variance explained. Yes, Anjali, are you trying to say something? Anjali raising hand.
Sir, I guess it's by mistake.
Okay, okay, okay.
I'll
Right,
just,
right, right, right. So if you see this total, yes, no problem. Total variance explained in the
Sir,
first. Yes.
sir, I just have one question. I
Yes,
don't
yes.
know where to ask it here, but
All right, no
I
problem,
have
no problem.
So how to like know which test will be applicable in which case, like Kornberg alpha and like or Barlette. These all are tests. How to like know where to apply which test.
No, no. See, whenever you want to conduct factor analysis, that means factor analysis is conducted to either summarize the data or to reduce the data. So once you want to use this factor analysis, so the primary requirement of conducting factor analysis is to see the correlation matrix. If correlation matrix is significant, then only you can move ahead with the analysis. If it is not significant, then you cannot do factor analysis. Suppose your matrix is significant, that means you are having this correlation matrix significant, Bartlett's test of sparsity is significant. Then you go ahead with checking the measure of sample adequacy, MSA, which is KMO statistics. So MSA, if it is overall it is more than 0.5, that is fine, but you have to check the individual variables, like we have checked the diagonals in the individual variables. They should be more than 0.5, like in this case we have seen, and then we have removed those variables one by one where this MSA is individual MSA, which is diagonal, is lesser. So we first removed 15 variable, then we removed 17 variable, and then we need also to remove the 11, because in the first case 11 variable, variable number 11, this was showing more than 0.5 loading, but when we remove two variables, this loading has increased, but it has decreased the loading of variable 6, which was there 0.8, now it is due to 0.5. That means there is something wrong with this variable also. So that we need to see actually initially, and then other variable, how many variable you want to extract, whether based on this Cree plot or you want to have based on the eigenvalue, that you need to decide as a researcher. If you see this Cree plot, then you can see this edge is there on the variable 6 variable. It says that 6 variables can be extracted based on Cree plot. But if you go by the eigenvalue criteria, then it is showing, in this case it is showing that 5 variable 5 factors can be taken, and which explains 81% of the variance. Now because we removed the variables and then we saw that how much variance is explained, now you can see it is showing that 4 variables are there in the second when we removed 15 number variable, and 79 is explanation, because we have to see different criterions. First, their measure of sample adequacy should be more than 0.5, and then we have to see whether the variable which is removed is how much it is affecting the other variable. So that has also been seen. When we removed variable number 17, it is explanation is 79%, and you can see that this 79% is explained, and there are 4 variables. Now I will show actually because people have not much time, so I have already calculated and will show how it happens. KMO statistics, I have removed 15, 17 and then 11, because 11 was causing disturbance to variable 6, which was having high loading 0.8, it reduced to 0.5. And if you see the correlation table also, there also it is having low correlation. Now if you see measure of sample adequacy, this I have already calculated, and from calculating these variable, removing these variable, we find finally the anti-image correlation, which is called as MSA. Coming to your commonalities, these also have changed. In the case of first case, you see 0.68 for the X6, then 0.681, 0.7 it has reduced, increased now. In the case of removing variable 17, it has improved to 0.768, but when we removed variable 11, it has increased to 0.798. I'll show also that how it is calculated. Now coming to variance extracted, when you removed this is the first one where 81% percent explanation is there, and what need to be checked is that here it is showing that there are 5 variables. When we have seen that the individual MSA is less than 0.5, so we need to remove these variables. So 15 variable is removed, and then it shows that there are 4 factors which are explaining 79% variance. Moreover, if you check here, first factor is explaining 29%, second is 24%, third is 14%, and fourth is 10%. Now if you remove variable 17, then you check that this first variable explanation has increased to 31, then second has reduced to 23, third has increased to 15, and fourth has reduced to 9. Again, if you see variable 11 is removed, then you see how much. Now the first has increased reduced to 30, second second is 20, second 2, and 16, and then fourth is 10. That means this removal of factors, they have actually redistributed the explanatory power of the factors also, and here it is also percentage wise also is shown that how much percentage variation it is having, and it is also shown that if you include all these 11 variables, then how much explanatory power they are having. Next is component matrix. That implies that when you have this factor loading which is without rotation, and then this you have squared factor loading. What happens is when we are talking about eigenvalues, what are these eigenvalues and all, this is the factor loading for factor 1, and all these values, they are squared. All these variables of factor 1, they are squared and then added. So addition is called as eigenvalue. The squaring of variables of factor and adding it up gives you eigenvalue. And when you are adding up the variables, when you are adding up the variable 7, suppose all the factors, 4 factors are there, when you are adding the variable 7 of these 4 factors, that gives you the commonality of 0.777. That means that how much commonness variable 7 is having with all other factors. So it is 0.77. That means this variable is having 0.77 commonness with all factors. So this implies that if you are having this factor analysis, this seems to be from a particular say concept. Yes, someone want to ask something? Okay, so this is how the commonality is say calculated, and if you see the addition or the sum of commonalities and sum of eigenvalue, both are same. So this is the data structure which talks about how these commonalities and how eigenvalues are calculated. Then comes the rotated factor matrix. When factor matrix is rotated, then these factors make a different structure, and that is how we can see that factor 1 in this case is having 9, 16 and 18 variable included. So these 9, 16 and 18 variable are complaint resolution, ordering and billing, and delivery speed, which are related to post sale service. So we can actually name them these variables like that. Similarly, second factor, which is having variable 7, variable 10 and variable 12 included, that means this can be given some name. These variable can be given some name from marketing, so that can be done depending upon individual researcher, they can give the name. So marketing aspect of it. And then factor 3 is having high factor loading 0.9 and 0.933 for 8 and X14. So these are product quality and competitive pricing, called as product value. Similarly, the factor 4, you can name these variables when they are finally rotated and then they come to say this level. Now you can ask the question, please.
Yes, the participants can either raise their hand or they can post the questions in the chat box. Just
Sir,
Hmm.
this is Sachin.
Hmm.
I have a question. As you
Yes.
said that, just a minute.
Yes.
Am I audible?
Yes. Yes. You are audible.
Yes, sir.
yes.
I wanted to know that
Hmm.
what value we should take for further analysis, which is
Okay.
better, whether it is average or a factor score. Because when
Okay.
I did EFA,
Hmm.
hypothesis testing by applying average of all the selected variables, I
Hmm.
get better result than applying factor score. So which method you suggest? I mean, which score you suggest, factor score or average for further analysis?
Actually, we have to try each and see what very the responses gave. When we were discussing, I am not actually in detail discuss their benefits and the demerits. But factor score is considered to be a better representation of the variable. Like in the first case, these are the four factors, 5 factors were there. So their scores are saved because we gave the command of saving them. So normally it is
Right.
assumed that the factor scores are they represent the whole data. So they should be used.
And so if I want to find out significance, suppose the 5 factors are derived and I want to
Hmm.
find out significance difference between male and female of
Hmm.
say factor 1. So I can take factor score of factor 1 as dependent variable and I
Hmm.
can go ahead with significance difference t test male and female. I can do so.
Okay, okay.
Shall, shall I repeat my question?
I can understand you, but
Yes, sir.
why do you want to have this factor one and then male and female score? You have
Suppose
better other better you have other better measures of doing this.
no, suppose my hypothesis is like suppose now 5 factors are derived and one
Hmm.
of the factor is satisfaction level, job
Okay.
satisfaction. There can be
Hmm.
another factor that is monetary satisfaction. There
Hmm.
can be third factor, some other satisfaction. Now my first
Oh.
factor derived is job satisfaction, and
Hmm.
I want to understand is there any significance difference between the job satisfaction of male employees and female employees. So can I
Okay.
take factor score of first factor as dependent variable and my independent variable is categorical, that is male and female, and significance difference between male and female by applying a t-test, taking factor score of first factor as dependent variable. Can I do so?
Okay. So in this case, uh, difficult to say. Otherwise, statistically, you can definitely go with that, but conceptually, whether we can, we need to see this. Suppose you are saying that job satisfaction is there. So, do we have other method of getting this? Like you have factor this job satisfaction. You have taken data of job satisfaction, and then you can easily go with the or you check both this one also and also the already
Average.
collected, yes, already collected data about job satisfaction.
Uh, but sir, again, the
Hmm.
already collected data about job satisfaction, suppose there are 20 items,
Hmm.
and after considering all, after running EFA on all 50 items,
Hmm.
10 items are have come together under factor 1 as job satisfaction. So I will be
Okay.
considering only those items,
Right,
no,
right, right,
for
right, right.
further analysis,
Yes,
because
yes.
items
In
which
this
are
case,
not
right. Right, right. In this case, you can use it because this is what the further analysis, whatever further, whether it is t-test or ANOVA or regression, you can definitely
yeah,
use these.
or simultaneously, otherwise I can go for average also, no,
You can
average of variable
actually
selected.
as a good researcher, you should check these others also. That see that what is the difference
Others
and
also.
why this difference is there.
Yeah, because whenever I did this, considering factor as well as average, I did always both,
Mm.
and I get different results from factor
No,
score
no,
and average.
it will be different actually. That is why, this factor score actually works on the weightage of each and every response. However, average takes the average of everyone. So that difference definitely will be there. That is why the
And
benefits, merits, and demerits of these methods are there. And even if you take
uh,
the surrogate variable, then also you are leaving other variable which may be contributing more but having less loading. So all these three methods they are having different their merits and demerits. You can definitely check them. If there is a very huge difference, then you need to check that which one to take. But normally this score will be better one in to justify that each and every variable is having their contribution in this.
okay, thank you, sir. So one last
Okay.
question. At
Mhm.
times, I have seen that there is only one factor derived.
Mhm.
So what to do in such
One
case?
factor,
Like
one factor means
I mean, like at times, like sample, suppose I have only 20 variables, and if I
no,
have
no, no.
20 variables in CFA,
Mhm.
so
So only
only
one
one
factor
factor is
comes.
derived. Rotation
Okay,
is
okay,
not possible, means I get
okay, okay.
unrotated,
See,
rotation is
see,
not
yes,
possible,
yes.
and only one factor is derived.
In that case, you don't directly go with the statistics only. You see what the theory says, or you decide that out of 20 variables, I will have four factors. So you have that criteria also that you can have four factors also, or you can go with the scree plot also. That scree, how much scree plot is uh, say advising to take these variables. So even if it is one variable coming, you go with the other methods of having three or four factors and then see what is the difference. Normally it should not come that there is one very factor is there. Normally it should not come.
Okay, okay. I'll try some other method, like
Right.
deciding number of factors rather than
Yes.
eigenvalue. Thank you, sir. Thank you very
Okay.
much.
Okay.
So there's one question in the chat box. What is the
Mhm.
minimum number of variables under a factor?
Minimum number. Actually, one is not recommended. One variable is not recommended, so more than one should be there. Ideally we have just seen that there should be at least five variable. When we were discussing the PPT, then there I have shown that at least five variables should be there. But even if five less than five are there, they are considered. But normally if it is sometime, it may happen that one variable is having one factor, so that type of situation is normally avoided, because in that case we will be difficult to have other calculations.
Thank you so much, sir.
Okay.
Any more doubts? Participants, are there any more doubts? Sir, I think there are no more doubts. Shall we
Okay.
conclude the session, sir?
Sure, sure, sure. Thank you. Hope I like you people liked it.
Definitely, sir. On behalf of TLC Ramanujan College and Indian Accounting Association, it gives me immense pleasure to deliver the vote of thanks for this session. I would like to express my heartfelt gratitude to you, sir, for sharing your knowledge about factor analysis in such detail. And the participants are already writing in the chat box that it's a very informative session. So thank you so much once again, sir, for taking out your time and
Thank you.
sharing all that you know with us.
Thank you very much. Thank you, everyone.
Thank you so much.
Okay, I'll take your leave now.
Yes, sir. Thank you. Participants, the details are going to be uploaded on your Telegram group. Please keep a track. For tomorrow's session also, all the details will be uploaded. Thank you.